Hello, everybody. Welcome, welcome, welcome. I'm gonna give a few more seconds before getting started. All right, let's start. I'm gonna ask you guys, I'm gonna launch a poll and ask you guys a couple of questions before we will get started. So just starting poll one. Please let me know if you guys are looking for software engineering jobs. Perfect. Where's everybody from? Write it in the chat. I would love to hear it. Nice. Oh la la, New York City. It's kind of late. Oakland. I love Oakland. New Jersey. New York City. Oh, nice. Toronto. Wow. Oh wow. India. Jesus. That's far away. Denver. Atlanta. I love Atlanta. I love the music they play on the road. New Jersey. And thank you for sharing. So most of you guys are looking for a software engineering jobs. Let's do another question. How many years of experience do you guys have? Nigeria, Jesus, that's super far away. Wow, that's crazy. San Francisco, right at the heart of San Francisco, huh? Okay. Thank you for answering your question. So it seems like everybody or most people are between around 6 years of experience, and we have some people, 6 people who have more than 10 years of experience. That makes me nervous. Okay, we have one more question to go and then we'll get started. What is, would you like to join the Slack channel, Outco Slack channel? Look at that. All right. Okay, thank you so much for answering the question. And we can get started. All right. Um, okay, I am gonna start the challenge, the question. So let's get started and talk about this. Okay. Who am I? My name is Sarah. I am a software engineer at Outco as well as a software engineer at Uber. For Outco, I work part-time, and for Uber, I work full-time. Previously, I was a developer at Okta. Okta is a cybersecurity company. And at Uber, I'm in their InSec team in San Francisco. I work with privacy, so in the privacy team. Who is Outco? Outco have worked with about more than 2,000 software engineers, resulting in 35% increase in their average salary. Nationwide, or I would say worldwide, a junior software engineer makes around 89,000, and so senior software engineer makes about $151,000. So if you like to join us, please let us know at the chat or come to our other classes and we'll be happy to help. Okay. So that being said, let's go to the coding challenge with Uber. So I'm gonna practice. I've done coding challenge both as a person who interviews and a person who as an interviewer and interviewee. So I'm gonna kind of switch between the modes and we'll go from there. So let's say you are in a technical phone screen and somebody gives you this question. And the question is, for this task, you will be given an element of a perfect binary tree of characters stored with a simple tree data structure, right? And your goal is to write a function, right, that starts at the root of the tree and returns a counterclockwise reversal of the nodes at the edge of the tree. Okay, so whenever I see a question, what I do is that this is kind of like a template that I always follow, and that is that the first thing is understanding. Okay, so that is there are four steps, right? The first one is understanding. The second one is that I want a diagram. Okay, the third one is pseudocode, and the fourth one is code. Okay, each one of them have subcategories as well. Okay, so in understanding, what I want to do is that I want to define the input and output. Okay, so no matter what question I have, I will follow these four steps, and this helps me understand or like come to a solution earlier than later. Okay, so I check out input and output, and I really make sure that this step I do it right, and then maybe check out constraints, and probably a couple of examples. Okay. So the reason we do this is because you have the idea of failing fast and failing often. You do not want to find or define a question the way you defined it, and it's not. It's called failing fast for a reason, right? And the reason for that is that you do not want to have a question, a solution for a wrong question, right? And that way, everything else that you follow will not be accurate, right? So what how I do it is that come up with different examples on my own and validate the answer before I move forward. Then diagramming is that you spend most of your time diagramming because you want to make sure that your diagram is accurate. That is where your solution comes in. Now, in terms of pseudocode, this is very interesting one because some companies do not like pseudocode. They want you as a software engineer to translate your diagramming directly into coding, and an example of that would be Google. For Uber, what happens is that you're not forbidden, or you can write pseudocode, but at the end of the day, it's ideal for you to have running code. Okay, so they always recommend you to have a running code at the end. So depending on what works for you, you go from there. Okay, so let's do the understanding part first. And then whenever I try to write the problem down, you will see that all the steps that I go through will have an element of these things, these four values, or these four patterns in it. Okay, so the first thing is that I want to define what does the input look like and what does the output look like. So we know that it says that the input is a kind of like a binary tree in a simple data structure, right? So I'm gonna ask for the input, and maybe my interviewer is gonna be like, okay, you know what? I'm gonna give you this input. Okay, I'm gonna write it down here. Okay, so this is the input. If I look at this, it just is very confusing and it doesn't make sense. So what I can do is that the next thing, right? I can come up with the example and maybe kind of diagram whatever I have here. Okay, so that tree, if I diagram it, it looks like something like this. Okay, so imagine I diagram it, it looks something like that. So now I can understand a lot better than previously, right? So now I'm going to go through this example input and figure out what the question is asking and what would the example output be. So this has always helped me where I get the input from the interviewer, then I'm going to go through the example as I understand it and check what the output should look like, and then I compare it with the interviewer, right? And then I can verify if the understanding that I have is correct or not. So and here, for example, the output should look like this. So far, from what I understand, it says that it should be traversing counterclockwise and it should look at the edge of the node, right? So what I can do is that, well, it seems like it's going to look at A, and then it's going to look at G, it's going to look at M, it's going to look at F, all the leaves, and then it's going to, because it's counterclockwise, it's going to go to Z and W. Okay. And this is a good place where you can understand if what's gonna, maybe I will ask my question to the interviewer as like, what's gonna happen to the P and U? Am I adding that to my values or not? Okay. So in here, I'm gonna, from my understanding, I'm gonna get A, and then G, and then M, and then F, and all the children. So C, S, R, T, O, K, X. Okay. And let's do the other side, Z, W. Okay. So, and then I compare it with my interviewer, and the interviewer is probably going to say yes. Okay. This is correct. Well, they are going to say it's correct because it is. Okay. Then this is the most important thing. Okay. Once you have gotten an input from your interviewer and validated the output that you have, come up with your own tree, with your own input, and see where you get that, where you get with that. Okay. So maybe I'll be like, okay, I want to have a tree that looks like this. Okay. That looks like this. Okay. What would the output for this be? Okay. Output. What should the output for this be? Should it be 1 and 3? So on and so forth, right? And the thing is, okay, so this is a good example, right? Because you have come up with your own example, now you understand how the input will work. So if I go back at my example, there is, the question says perfect binary tree. Okay, so because you have come up with your example, you can figure out, if you missed what the perfect binary tree is, then you can catch it up here, right? So sometimes you miss few things that are in the instruction because it's not what the value looks like, right? You don't catch them. So there are a couple of problems here. Okay, the first problem is that, okay, this is a perfect binary, it asked you for a perfect binary tree, then maybe you don't know what a perfect binary tree is, so you're maybe you ask what is a perfect binary tree, right? I'm going to write it down, binary tree. Okay, and then you figure out, you and your interviewer figure out that the perfect binary tree is a tree that every non-leaf node has exactly 2 children. Okay, so if it is not leaf, it has 2 children, and if it is leaf, all the leaves are at the same level. Okay, so now you can modify your input, and at the same time you got these constraints that you kind of forgot about. Okay, so I'm going to modify my input to be like this. Okay, 3 and 4. Okay, so now I know that if it is non-leaf, which was 1, it had 2 children, and if it were children, it were in the same level. So 3 and 4 is in the same level. So now I know that next time I looked at a tree like this, right? This is not a perfect tree. The children all has to be in the same level. Okay. The other thing that I can figure it out is that if my interviewer sees this and I says, okay, no, the problem also checks if it is only characters. Okay, so the 1, 2, 3 that I have doesn't work. But if I have like V, H, L, and all that, then that will work, right? Then so you have defined, or kind of surfaced few things. You've defined that it was a perfect binary tree and kind of like notified it in your brain. Then you know that it's like only characters. And one thing that you could ask your interviewer would be that, okay, are these characters unique or not? So in this scenario, I know that they are unique. Okay. So far, you know that we haven't solved anything, right? We are defining the input, and then we are defining the output. And then the last thing you need to do with your interviewer is that you're saying, okay, I'm expecting this in the output. Would that be accurate? Okay, and they're going to say yes so far. So what we did was that we diagrammed our input, and we guessed our output, and got approval from interviewer. Then what we did was that we had a random, so far, like a random tree that we didn't understand, right? We created a tree, and then we kind of modified it to fit the definition of our input, and then we produced the output. Okay, so if you have two examples and you go through them one by one, then you understand, most likely you will understand what the input and output exactly look like. Okay, so now that we have input and output, when we kind of got the constraints and things like that, we have to go through the next step, which is kind of diagramming. Okay, so as I said, diagram is kind of like important, one of the most important element of whiteboarding or phone screen, and you do not want to skip that, because that shows your problem solving skills. Even if I've had interviews where I solved the problem completely, but because I didn't go through problem solving, diagramming, I did not show that I have a problem solving skills, and therefore I was rejected. Okay, so how do you diagram? If I had a whiteboard, it would be helpful, to write it in the whiteboard if I was on site, right? But since I don't have whiteboard, there is a note that we need to make here. First of all, you can have a whiteboard in the back of your, like, if you're doing phone screen or virtual now, you can have a whiteboard that in the back of um, your class, or even virtual whiteboard where you can share. But keep in mind this, that if you have a whiteboard and you draw all your diagram there, when the interview finishes, interviewer only will have access to this, to something that is not your whiteboard, right? Your design and whatever you had, they're gone. So that's why I recommend always to do all of them in the coding IDE that the interviewer presents, right? It's important to have it in a sense, for future references for the interviewer. So I'm going to use this, right? Now that I use this, I'm gonna check at what are the next steps that I need to make, right? If I think of it, if I go through the solution, or the introduction of the problem again, it says that it starts at root and then it goes counterclockwise, right? So it starts at root, and then it goes to G, and it goes to M, and then it covers all the leaves, and then it goes to the Z and W. Okay, right after that, I know that somehow there are three steps in this. Okay, somehow I have to go to from the root all the way, and cover all the leftmost sides of the tree. Then I have to go through the leaves, and then I have to go through all the rightmost side of the tree, and make sure that from the rightmost side of the tree I cover from the bottom up. Okay, so let's do that. I'm splitting the problem into three pieces, if you can see. One of them is how to solve from the left side, and then how to solve for the leaves, and then how to solve from the right. Okay, so let's check one problem at a time from the left side. Okay, so what I'm going to do is that I want to have a pointer start from A, from the root, and then goes to all the way to the next left, and then the next left, and then the next left, until it hits null, right? So I'm going to start a traversal that goes from root to all the way to the leftmost side null, and each time it's going to do something. So it starts from the root, and then it outputs the value, or put it in the result, and then it goes to the next value, it outputs the value, put it in result. So okay, get the value and add it to the result array. Okay, maybe we have a result array, and traverse to the next node. Okay, so on the left side, what we are doing is that we are getting the value, adding it to the result array, and then we are going to traverse to the next node. Okay, now let's go to the leaves. on the leaves, what I do is that, okay, this is very interesting and some people might miss it. Okay, I need to get all the leaves there are, right? So I cannot go on the left from root node. I cannot go to the left, and then from F I cannot go to the C and so forth. Just jump between these. I cannot do that. So that's why I have to go from. I have to traverse the full tree, right? Because in order for me to get access to S, I have to go through the P, and in order for me to have access to P, I have to go through G. Okay, so I need to traverse the full array. Okay, um traverse the full array, sorry, tree. Okay, and if the value if the node is a leaf node, mm, add node, add the value to the result. Okay, okay, so I really like people to participate. If you would like to participate and walk me through this, please feel free to do that in the chat. I've kept it open in the side, so I'm going to keep looking at them, and that will be super helpful. Okay, so in this step, what I'm doing is that I'm going through, as soon as I found that how the leaf, I found the leaf, I'm going to add that value to the result, and then I'm going to traverse, or traverse just means looping through and going through each element. Okay, okay, so how do we find out what the leaf is? Okay, so can you guys tell me, how do I find out, how do I find out that this is a leaf? This, for example, F is a leaf. Yeah, perfect. So this is the perfect value comes into, perfect tree comes into. So I don't have to check if this F has a left tree or left child or a right child. If as soon as I know that this, for example, F value does not have a left child, I know that it doesn't have a right child either, because they were in the same level. Remember, a perfect binary tree, the children are in the same level. So I don't have to check both of them. I can just check one. As soon as um, if node uh, if left of the current node is null, okay, then the child is a tree. The node is a child. Okay, so let's go to the right. So in the right, this is very interesting because it is similar to the left, right? So you go from A to G to M, but it is different in a sense that you go upwards. You don't go, you start from, you go from like Z to W, right? You do not go from W to Z, right? So it's upwards. And all you need to do is to reverse this order here. Okay, to this order here. So instead of having to create the action before, you just create the action. This is the action. Instead of having it before, you just have it after, right? You traverse the values and then you add them to the result array. Okay, so we are kind of done with the pseudocode. Now we are gonna launch another poll asking, yeah, so feel free to update that as you go. Okay, we'll go through the next steps. We traverse through the left, leaves, and then the right. Okay, and let's go and do that in terms of coding it. So I'm going to create a function, and then I'm going to say left traverse left. Okay, And in here, what I'm gonna do is that maybe I will give it a tree. No, we are gonna call it current, which is the current node that I have. And then I'm gonna pass in the result value that I got so far, okay? So basically I'm gonna do this, okay? So we know that the base case is that if I'm going to keep going, until my left value is null. Okay, so let's do that as a base case. So my base case is if my current dot left is null, right? So if current my left, that means it exists. But then if I do this, that means that it's null, correct? Okay, then I'm gonna what I'm gonna do is return the result that I get so far. So I'm gonna add the values to the result, right? Actually, let's do that here. So I have something to add. Result dot push, okay, and that's gonna have current dot value, okay. Then I'm gonna have to call the traverse function again, but this time I'm going to give the left value, okay, and dot left. Okay, so I'm recursively calling this function on the left side, and I'm adding the values to the result, and at the end I will have an array of results to return to, right? And in here I'm gonna just return that result that when it's base case, so I don't miss it. Okay, so if I call this function, what I want to get is all the leftmost sides of the values. Okay, and let's console. Actually, I think I can do this. I don't have to console.log, and this one will have the tree, and this one will have empty array at the beginning. This tree is defined earlier in here, so I don't need to define it. Okay, so what I'm expecting is that I'll get this, okay, and let's run it, see what we get. Okay, I get A, G, M. The reason I didn't get F is because I am going one step. I'm saying if current dot left is not null, right? And that way, because I want to get all these values of the leaves in one array, okay, in a different array. Okay, so let's have another. I'm gonna, you know what? I'm gonna comment that out. No, I'm gonna write this down. I'm gonna create my next function, okay? And then I'm gonna call it traverse leaves. Okay, it's gonna get current as well. It's gonna get res. And then in here, what I'm doing is, according to this, I'm gonna figure out if the okay, so I'm going to define what my value is if it is a leaf, right? If the left side of the current null is null, then we know that the value is a leaf, and I'm going to add that to the result array. Otherwise, I'm going to traverse to the left side and I'm going to traverse to the right side. Remember, we have to traverse through the whole tree this time. So for that, I'm going to just do this. If current dot left does not exist, I know that this is a child, so I'm gonna add the value to my result. Current dot value, okay, and then I'm gonna return the result. Right now, what I'm gonna do is that the next step is that I'm going to traverse to the left and I'm going to traverse to the right. Okay, I'm going to call this function traverse current to the left, okay, traverse to the right, okay, and I do that and return res. So this one should give me all the leaves of this node, okay, and I call this function. I'm going to give it 3, and then I'm going to give it here. Okay. Okay, so let's look at the here and look at all the children. Okay, so it starts at F, it ends at X. I have all the children. Okay, and then let's do the last traversal. Okay, so the last traversal was, if you look at this, it's exactly the same thing as the first traversal. Left and right is exactly the same thing, but the orders of operation is reversed. Okay, so I am gonna check at the right. Okay, um, and then I'm gonna check. This is the same thing as we have earlier. So this one goes after. If you check, I can show you guys what we did there. So we first of all traverse and then create the action, right? Our action is adding the value to our current result. And let's call this function the same because we're doing recursion, right? And this one is not left, this one is right. Okay, and so this one, and then if this is right. Okay, so basically all I did was switch these two statements together, and what I'm thinking is that I should this time, because I've switched these statements together, I should get Z, W, and A. Okay, so let's check that. This is 3 and this is empty array. Okay. Uh-oh. Okay. Okay, perfect. Um, now we are going to add them all together, right? And then we are going to figure out why this is probably not the solution that the interviewer wants. Okay, so let's create a result. Res, I'm going to call it that because I don't want to keep changing it. And then I'm going to go call res.push, and I'm going to call this function left. Okay, I'm going to call left. So this traverse left is going to give me an array if I add the values, right? Which is this one is 3 and this one is an empty result. It's going to give me an array, but I don't want my array to be inside another array as an item. That's why I'm using this 3 dots in JavaScript. All it does is that it pulls the items from the nested array out inside the first level array. Okay. Now I'm going to do another one, and this time maybe I should do all 3 and just change the value. Okay, so this one should be leaves. And this one should be right. Okay, let's actually give this the right value, this one the left value, the left. Okay, and return res, and I want this guy to return everything that we want except the parent node, because I haven't added that to my value. Okay, so let's see. Okay, so if you look, it's everything except A, and let me add that value here. Res dot push 3 dot value. Okay, and one check that I want to do is that if you have, if you're the only node that you are, like you have, if and then the tree is just one node, then you don't want to go through it. So I'm gonna say if tree dot left does exist, then you do these things. Otherwise, you just return the value that's in the result value, which is like one value of one node, right? Okay, so they should return the value. Okay, Okay, once you've solved this problem, what will probably your interviewer say? Do you guys have any suggestion? What will your interviewer say? Okay, I can say it. The interviewer is going to be like, okay, can you do better? Because the time complexity of this seems to, yeah, exactly. How can you make it better? Because you're basically going through the whole tree here, right? And then you're going through the side, left side here and through the right side here. Maybe you can figure out a way to just not use that much time complexity, or like how can you make it bigger? How can you make it like in one pass maybe? Okay, that's probably what I would say. So if I say that, the question is usually yes, and that's what I would do. Okay, so it seems like what I can do is that I can call, I can traverse through the whole, um, maybe I should copy and paste this here so we don't have to go all the way up. Okay, so they're going to see this and they're going to be like, okay, maybe, or you're going to see this, you're going to be like, maybe instead of traversing it 3 times, I can traverse it 1 time and somehow figure out what is the left side and what's the right side, right? Because for the leaves, you really do not need to do anything. Everything is traversed anyways. We just need to figure out how the left side, how we can incorporate the left side and the right side to the values. So what I'm going to do is that, okay, I'm going to traverse through the whole list. And how I can do is with a little thing called creating function inside function. It's called helper method recursion, where you are the value that you need for the recursive method is stored in another function that is a global value to make it like kind of like have a global value. Okay, so I'm going to have a function. This function is going to be my recursive function that goes through traverses the whole through the whole array. Okay, so there's going to be my mega recursive function, and in here I'm going to can give it tree. I know I'm going to give it tree, but let's call it current. Okay, now maybe I can call, if I can figure out how to keep a value, right? A Boolean value that says if it is the leftmost sides, right? What if I, and I know that at the beginning, I know that, right? I know that A is the leftmost side and the rightmost side, most side of my tree. But then I know that as soon as I go to the left side, then this one is not the rightmost side, but it's the leftmost side. So basically what I'm doing is that at each value, I'm going to have a recursive, a Boolean that either keeps track of if it is the leftmost side of the value or not. Okay. Or if it is the leftmost side of the tree or not. Okay. So let's have that. I'm going to have a leftmost, and then I'm going to have a rightmost. Okay, and these are maybe a Boolean. Okay, we'll figure out how to keep track of them. So the next thing, because it's a recursive and I don't want to forget that, I'm going to call this function and feed it a tree. And if I'm at this index, which is the tree, right, the root node of the tree, A is true for the leftmost side, true, not tree. Okay, and it's also true for the rightmost side. Okay, so and because we are here, let's create a result array. Okay, and at the end we are going to return it. Okay, so this is what magic is going to happen. So the base cases, I would say. Okay, base, you know what, I'm not going to write that. I'm gonna define how do you, what the first base case is, how do you get the leaves, right? So leaves are added to Okay. And you know what? I already have that here. Okay. And this is the definition. Because I'm not traversing, because I'm traversing it later, right? It's like one mega traversal for everything. So the logic of getting a leaf is this one. So that's a base case. I'm gonna add that there. Why are you doing this to me? Okay, that's the leaf. Now let's look at the left side. Left side. Okay, the left side is okay, so this is the left side, right? The left side, I'm adding, the only thing I'm doing, the only thing that I need to do is to add the value to the result. But here's the thing. Here that it doesn't have, it has a Boolean value that keeps track of the left side. So all I say is that if the leftmost is true, right, the leftmost value is true, then I know that the current value belongs to my result array. So maybe I will just copy and paste this here. Okay, now this is interesting with the right side, right? The right side, if you look at here, right, what happens is that the traversal happens first and then adding the value happens, unlike the left side. Okay, so if you look at the leaf, the traversal, the action happens first before the traversal, right? On the left side, also the action happens before the traversal. However, on the right side, the action happens after the traversal. So let's figure out how to do the traversal, okay? So how do we do the traversal? Can somebody write me in the chat? Yeah, okay, I can say that. The traversal happens like this. You traverse on the left side of the tree and on the right side of the tree. Okay, in here you give it the left, in here you give it the right. Okay, so if I go to the left, right, I'm on the leftmost side. What do I put for the left value? If I go to the left, right, my left value will always be true, which is this value, and then my right value will not be true. So I'm going to add the value false, right? And the right value is opposite. So I'm saying that if you go to the right, keep the value true, right? And keep change the next value or the left value, because on each character you have to change the values. Yeah, perfect. So we are almost there. And what I need to do now is figure out how to add the value of the right? We have done everything else. And in this scenario, all I need to do is check if the value that I have currently is the right value. So if rightmost, okay. One thing that this is kind of something that probably will be got you is because you go through the whole recursive element, you want to make sure that your left is not, okay. So you're saying that left, if not left and right, this is when you get these values, okay. Then you add the result to your array. So I'm going to do exactly as I did all this 2 times. Okay. Now, because we are still inside our recursive function, I'm going to return the return res. Okay. Now I'm calling the traversal function, and then that maybe I will give this a call. You know what? There are 2 of them, so I have to comment this out. And I'm expecting to get whatever is here already. Okay, nice. Just to make sure, a sanity check, I have a code signal that I can copy paste it there to just do some testing. Hopefully I don't have the code there already. Oh, okay. I can find that as we go. Let me actually check. But feel free to ask any questions you guys have. I am good for now. I'm gonna send you guys the link. You guys can test it yourselves. Okay. It seems like I do not have the. How do you give it to everybody, not the panelists and attendees? Okay, here you go. That is the question. Please feel free to copy and paste. Meanwhile, I'm going to try to find code signal that had the question. I don't know why I deleted it, but feel free to ask any questions you guys have. Mm. Oh, I see there were some questions beforehand. Why not use traverse tree to add the root node? If you do that, that is accurate, but you have to make some test cases because you want to do that with the write as well. This is a little bit cleaner, but you could if you want to. Um, all right, guys. I think I found the question. I don't think you guys will have access to it, but I found the code signal, so I'm gonna share that. Just for sanity check, I'm gonna paste it here. Mm, this. Okay. Hmm. This is weird because I have to keep sharing two screens. Do you guys see the code signal one? I think yes. So I'm going to do the other one. So this one is the other question, the other one that was a bit expensive. You can see. And if we run that, okay, perfect. Okay, now that you guys have covered that, there is this other question that is very similar to what we have covered, and I hope you guys do that on your own. So I'm going to drop it in the chat so everybody have access to it. Perfect. Okay, so you guys covered that. Um, that is it from me. If you guys do not have any question, thank you so much for attending, and I enjoyed this. No problem. I'm gonna be here for a little bit, just to see if you guys have any question. Bye. Bye, everybody. Have a good night.